Today, we're diving into something pretty cool, how a special kind of AI is helping us predict and, more importantly, prevent major failures in our power grid. We're talking about the tech that literally keeps the lights on.
You probably don't think about power transformers very often. They're these silent workhorses, the absolute heart of our electrical system, running 24/7. But when one of them goes down without any warning, well, that's when things get real. We're talking blackouts, super expensive emergency repairs, and just a massive headache for absolutely everyone involved. Now, you'd think in this day and age, with all the data we have, predicting these failures would be a piece of cake. But here's the twist. The research we're looking at today brings up. The biggest problem isn't that we don't have enough information. It's that the data we do have is often messy, incomplete, or just plain broken because of sensor glitches out there in the real world.
So let's really dig into this whole broken data issue. Because really, it's the very first wall that scientists and engineers hit before they can even start building these fancy predictive models.
Okay, first things first, let's make sure we're on the same page about the end goal here. It's all about something called predictive maintenance. The whole idea is to use data to spot the warning signs of a failure before it happens. It's a difference between a routine, scheduled checkup and a chaotic, middle-of-the-night trip to the emergency room.
I love this analogy because it makes it so clear. Just imagine all that sensor data, temperature, voltage, you name it, is like a transformer's daily health diary. Now, what happens if sensors fail and whole pages get torn out at random? How could you possibly get a clear picture of its health? You're left trying to piece together a story with crucial chapters missing. So how in the world do you solve a problem like that? Well, this is where things get really interesting. The paper proposes a super clever AI-powered solution. It's this whole framework that doesn't just try to predict the future. Its first job is actually to clean up the messy, incomplete story from the past.
And this approach is so methodical. Look at this. First, it uses AI to intelligently fill in those missing data points. That's called imputation. Then, it dives deep into the data's frequencies to find hidden rhythms and patterns. After that, it groups similar operating conditions together. And only then, once it has a complete and well-understood dataset, does it finally get around to forecasting what might happen next.
This is such a critical point. Before the AI can put on its fortune teller hat, it has to be a world-class detective. Its number one job is to look at those torn-out diary pages, those data gaps, and use all the surrounding context to brilliantly reconstruct what was written there. This single step is a total game changer for getting reliable data.
Okay, so which AI is the best tool for this job? Well, the researchers didn't just pick one out of a hat. Nope. They basically set up an AI bake-off, a competition pitting several different types of deep learning models against each other to see which one really had the right stuff.
Let's think of these models as different kinds of specialists, each with its own superpower. On one team, you've got your LSTM and GRU models. These are the memory experts. They're incredible at remembering important details from way back, which is perfect for spotting those slow, creeping problems that build up over months. On the other team, you have the pattern spotters. CNNs are amazing at finding recurring shapes in the data, like a daily temperature cycle. And the dense models? They're your powerful, no-nonsense workhorses, fantastic at finding the most direct connections between different readings.
And when it came to that very first crucial task, filling in the missing data, there was a clear winner. Just look at this table. The CNN model, right there at the top, it just hit that perfect sweet spot. With a correlation of 0.89, it proved to be the most stable and accurate, rebuilding the missing data without messing up the natural patterns.
All right, so the data is now squeaky clean and complete. The stage is set for the main event, actually forecasting the failures. And let me tell you, the results of that AI bake-off had a few curveballs.
Check out this chart. It's fascinating. While those really complex memory expert models like LSTM did a good job on some things, it was actually the simpler, more straightforward dense model that consistently came out on top with the highest accuracy. It's a great reminder that in the world of AI, more complex doesn't always mean better.
And this number right here just drives that point home. An R-squared score of 0.91 is just, wow, that's incredibly accurate. So why would this simpler model win? Well, in a noisy, messy, real-world environment, a super complex model can sometimes overthink things, seeing patterns in what's actually just random noise.
The simpler dense model, though, it cuts right through the clutter to the most powerful direct relationships, which makes it way more robust. Sometimes simpler really is smarter.
So, what the authors ultimately concluded is this, and it's a huge takeaway. There is no magic bullet. There is no single AI model that's perfect for every single part of the problem. The best, most reliable solution is actually a hybrid approach, a whole ecosystem of AIs, where different models bring their unique strengths to the table and work together as a team. So what does this all mean for us in the real world? It means we're on the path to a future with much smarter maintenance, which ultimately leads to a more reliable, more resilient, and more efficient energy grid for everyone. So let's just boil it down to the key takeaways. Number 1, AI can be a detective and fix our broken data. Number 2, sometimes the simpler model is the smarter choice. And number 3, a team of AI specialists working together is the most powerful solution. And all of this leads to a grid we can all depend on. And the impact here is not small potatoes. We are talking about massive improvements. The paper actually cites a McKinsey study showing that this kind of predictive maintenance can slash repair costs by 25%, free up nearly half the workforce for other important tasks, and this is the big one, it can cut accidents by 50%. These are absolutely transformative numbers. And that brings us to our final thought for today. This research gives us an incredible blueprint for keeping our power grid safe. But it really makes you wonder, right? If we can use this detective first, fortune teller second AI approach here, what else can we apply it to? Water systems? Transportation networks? The possibilities, well, they're pretty electrifying.